in this case, we are talking about the useful work. So useful work refers to the energy that is converted to gravitational potential energy to bring the person upwards. Okay, so we are talking about gravitational potential energy here. So the gravitational potential energy of this person, it can be calculated by mgh, and mg is actually the weight. Okay, so it's actually the weight multiplied by the height. So it will be 600 multiplied by the height, the vertical height, which is 3 meters. So we get 1800 joules. Answer B. To find the kinetic energy, we use the formula Ke is equal to half mv squared. So it's equal to half multiplied by the mass, which is 0.3 kg, multiplied by the speed, 20 squared. So if you were to calculate this will give you 60 joules of energy. Answer D. Okay, the power of the kettle is 2.5 kilowatt. So we change this to watt, we know that it is 2500 watt. And the time taken is 3 minutes. So that means that the time is 3 times 60, which is 180 seconds. So to find the energy transferred, you can use the formula energy is equal to power times time. So power is 2500 and the time is 180. So we will get 450,000 joules. Answer D. Okay, we have to understand that the volume is constant. Okay, next, when the sunlight falls on the tire, the temperature of the air is going to increase, and this will cause the kinetic energy of the air particle to increase. So now the air particles are moving with a higher speed. So that means that they will hit the wall of the tire more frequent, which will cause the frequency of collision to increase. And also, because they are moving faster, the force of collision will increase as well. And the increase in the frequency of collision and the force of collision, it will cause the overall pressure to increase in the tire. Okay, so now let's look at the option. Pressure, temperature increase, pressure, temperature increase. So we're left with option A and B. And now let's look at the mass. Okay, the mass of the number of particles in the tire remains constant. So there will be no effect on the mass, it will remain the same. So the answer is B. Okay, when a gas in a closed vessel is heated, what happens to the molecule of the gas? Let's go through the 4 options. Okay, for option A, the average force between the molecule will only change when there is a change in state. So it's wrong. The average separation of the molecule increases. Okay, this is also not correct. Okay, because the gas molecules, they are in a constant volume. So the average separation should be the same. And the kinetic energy of the molecules, it should increase because it's heated, and the temperature increase, the Ke should increase. So this is wrong. And the rate of collision of the molecules within the vessel increases because now they are moving faster, so they collide with the wall of the vessel at a higher frequency. So D is the correct answer.